So we're trying to solve this equation. Sine of x squared is equal to sine of x. And this should be easy, right? Because we can just cancel the signs out, and then we get x squared equals x. And now, because both sides have x, so we can just divide this by x, likewise there. And the left-hand side gives us x, and the right-hand side gives us 1. Done, right? No, this is not okay. Firstly, this is wrong, and this is also wrong. Alright, let's talk about why this is wrong. Do not cross out the signs, because otherwise you won't be able to get all the solutions. And the reason is because the sine function is not what we call the 1 to 1. So what I mean by that is, if you take a look at the sine graph, looks like this, right? This is y equals sine x. If you draw a horizontal line, let's say somewhere right here, you can see that the horizontal line crosses the graph more than one times. In fact, infinitely many times. So the idea is that when we have one y value, it will come from many different x values. And that's what we mean by not a one-to-one function. So here's an example of a one-to-one function. Right here, suppose we have e to the x squared equals e to the x. Then in this case, yes, you can really just cross out the e, and then you can just look at x squared is equal to x. And the reason is because if you look at the graph for e to the x, this is y equals e to the x. No matter which horizontal lines that you draw, the horizontal line will only cross the graph only one time. Right? The horizontal line will only cross the graph at most one time. Of course, this horizontal line does not cross the graph at all, but anyways though. So this is the idea of one-to-one. When you know a function is one-to-one, you can cancel it out. If it's not a one-to-one function, cannot cancel it out. So that's the first thing. Now, this is also bad. Why though? We can cancel the x on both sides. No, because here, in fact, x equal to 0, it's a solution. So when you divide both sides by x, you are dividing by 0. And in fact, you are just going to forget about this answer as well. So don't do this, don't do that. But now, what's the correct way to do it though? So here's the deal. In order to find out all the possibility for this kind of equations, we are going to consider two cases. Here's case 1. Firstly, notice that the period for the sine function is 2 pi, meaning that you can keep adding 2 pi inside or keep subtracting 2 pi inside, and you will still end up with sine of x. This is equal to sine of x plus, well, it's an integer multiple of 2 pi. We can write that as 2n pi or 2 pi n, up to you, where n is an integer. Now, when we have all the possibilities here, you can just really look at the inside, just cancel all the signs. So, case 1 is we use this being equal to that, and we can say x squared is equal to x plus 2n pi, where n is an integer. Alright, and now we have a quadratic equation. Move these two terms to the other side. And then we can just use the quadratic formula for it. X is equal to negative b, which is negative 1, plus or minus, square root of b squared, minus 4. A is 1, and c is negative 2n pi. And then all over 2 times a, which is 1. And then we just have to clean this up a little bit. So x equals 1 plus or minus square root of, this is 1, negative 4 times negative 2 is positive 8, and then we have the n pi left, all over 2 times 1, which is just 2. So yeah, that's case 1. Now, earlier I said n can be any positive or negative integers. However, you can see that n ends up to be inside of the square root. In order to avoid complex answers, we will have to avoid negative n's. Because if n is equal to -1, then you will get 1 minus a pi. You end up with a complex number. Unless you really want to though, but I'm going to say it right here. N is an integer, but make sure n is greater than or equal to 0. 0 works okay. And notice if n is equal to 0, you get 1 plus 1 over 2, so the answer is 1. The other answer is 1 minus 1 over 2, you get 0, which are the two answer if you don't have that part. But anyways, that's case 1. Now, case 2. For case 2, first we are going to use the idea that when we have sine of x, this is equal to sine of pi minus x. Why? Well, because it's on my board right here. Okay, I know. I'm going to show you guys a reason real quick. So, let's talk about the unit circle. And the sine value is just the y value on the unit circle. So let's say we have this point right here. And then let's say we have angle theta. So this is cosine theta comma sine theta. We have to think about where else can we have the same y value. Just go here, right? Like this. Now this is just a left-right reflection. This is the angle theta. This will also be the angle theta. But to measure the angle, we have to go from here to here. So from here all the way to here, it will be pi, right? 0 and pi. This is theta already. So this red angle will just be pi minus theta. So for this point here, we will have the y value sine of pi minus theta. So sine of x is equal to sine of pi minus x. Then we can just go ahead and do what we did over there. So we will have x squared equals, put on this angle, and then just add the same part right here. And once again, we have another quadratic equation. And right here, I am just going to keep this on the left-hand side, move this to the left, so it becomes plus x. And then these two things together, because they both have the pi, I can factor that out and then put a pi at the end. This is 1 and then 2n. So I'm just going to write this 2n plus 1. And on the right hand side, it's positive. I'm going to move to the left, so it becomes a minus. And then we have 2n plus 1. And then pi, that's equal to 0. And then once again, use the quadratic formula. X equals negative, and b here is 1, plus or minus square root. B is 1, minus 4, a is 1, c is negative, and then 2n plus 1, pi. And then all over 2 times 1. So x equals, this is negative 1 plus or minus square root 1, negative times negative, and 4 is right here, and then we keep the 2n plus 1 like this, and then the pi all over 2, like that. And again, here you have to avoid that n cannot be negative. If n is equal to 0, it works okay, but if n is equal to negative 1, once again you end up with, that will be negative 4 pi, 1 minus that, it will be a negative. So again, n has to be an integer, but it has to be greater than or equal to 0. By the way though, I found out that on ChatGPT, it actually solves this one very, very nicely. So now let's have a look.